let's quickly mark. Okay. Alright, the first one there, please remember, when you have an x squared, we need to get everything on the same side and 0 on the other side in order for us to factorize. So I took the 25 over, and then I see it's the difference of two squares. I get my two answers in the brackets plus 5 minus 5. Those I need to know my 0 points. Remember, we look at the function just before we factorize. That will be the standard form. That's a positive graph. Do you agree with that? Okay. So the question asks, where is this graph greater than or equal to 0? So I want you to imagine that parabola in your head. It's a happy face because we made it positive. If it wasn't positive, we would make it positive. And then it will be or the y values will be positive. Then the 0 point negative, 0 point positive. So when they're asking where is this graph greater than or equal to 0, then we know it's on the outside of the 0 points, right? I told you that yesterday. You can learn it and then know. If they're asking greater than, we know it's on the outside. When they're asking smaller than, we know it's in between the two 0 points. So I know it's going to be x smaller than or equal to -5 and x greater than or equal to 5. When you write it in this notation, remember the infinity, whether it be negative or positive, will always have a round bracket because it's not a specific answer. But how do I know whether this -5 and 5 must have a block bracket or a round bracket? Who can tell me? When the question asks greater than or equal to, remember those are equal or 0 points. So there they are equal to 0. Does that make sense? Okay? So when the question is greater than or equal, then you will include the 0 points because there they are equal to 0. When the sign looks like at C, where it's just the greater than or the smaller than, then they are only asking for negative or only asking for positive. They're not including 0. Okay, who got that B right? Good. It doesn't matter which format you write it in. You must just choose one. But they can't be written next to each other, ne? Can't be written smaller than -5 and greater than 5. You remember we spoke about that yesterday. Okay, see, I get everything on the same side. It's x squared minus 9 smaller than 0. I get my 0 points. My two 0 points will be 3 and -3. They're asking for smaller, so I know it's going to be in between the two 0 points. Then I write it as 1. X is greater than -3 and smaller than 3. You mustn't swap these two values around. I told you that's like writing your name from the wrong way around, eh? Backwards. And if you write it in the other notation, you'll write from -3 to 3. The 3 is not included because they're only asking for smaller than. Did you get it right? Okay, F. Get everything on the same side. Easy factorization. You've got your 0 points. They're asking for smaller. Ne? That's the standard form. Right before I factorize, they're asking for smaller. So I know it's going to be in between those two answers. Don't put the 4 on the left and the negative 3 on the right, then you get 0. H, 4x squared greater than 9. I'm going to take the 9 over because I see the square. I know it must be 0 on the other side. Then I see perfect square minus perfect square. Do you all see that? So I can factorize it, the difference of two squares. I get my two answers. Do you see that question or the sign before I factorized? It's asking greater than. So I know it's on the outside of my two values. So I have to write it separately. X smaller than negative 3 over 2. X greater than 3 over 2. And there's the other notation. You happy? You understand that? Okay. There it was. If you're afraid of a coefficient factorization, you're welcome to use the formula. But you see 2 is prime and 3 is prime as well. So it's actually not a difficult factorization. You get your 2 0 points. It's negative a half and 3. The question is asking smaller than 0. So that's how I know it's going to be in between negative a half and 3. If you use the other notation, negative a half to 3. Remember round brackets because they're not asking equal to as well. Do you all understand? Okay. J. I spoke to you about this one before you left yesterday. This is the only one that is khocha. It's the only one that has a trick. And you had to be awake to notice that that 2x is not standing at the right place. Do you all agree with that? It must be x plus minus whatever constant term. And x plus minus whatever constant term. This is the wrong way around. So what I'm going to do is I'm going to take out a negative in this bracket. Then they swap around. Do you remember that trick, ne? Okay, so I take the negative out, then the two of them only swap around. It doesn't influence both brackets, just one of them. Okay, this influences one bracket. And now I've got a negative here, but I can't have a negative here, so I'm actually multiplying both sides with a negative, or you're saying you're dividing with a negative. And when you do that, do you remember what happens when you multiply divide with a negative? The sign turns around. So now it's the one that I have to answer. Everything has been done. It's now in standard form. They're asking for greater than. Can you see that? Greater than means on the outside of the 0 point. So the two 0 points will be a half and 3, and it's on the outside of them. Smaller than negative 3 and greater and equal to a half. Also with the brackets like that. Gali, put on your mask or close your mouth when you're eating. Yo. K, the catch at K, and the reason I chose this one for you is because many times they put in this type of question, especially when they ask you to solve for X in question 1 and 2 of a question paper. So when you look at that, I want you to understand that this thing has not been factorized correctly. Because on the other side I have 12. We can only do the bracket thing when it's 0 on the other side. So I'm going to have to multiply it out first, then get the 12 over to its side again, and then factorize again. Do you understand that? Okay, so I multiply that out, I bring the 12 over, it's minus 12, and then I'm left with x squared minus 7x greater than or equal to 0. How do I factorize that thing? Take out the x. Can you see this is now the standard form right before I factorize? So the question is greater than, it's going to be on the outside of my two answers. The two answers that I get is 0 and 7. So x is going to be smaller than 0, smaller than or equal to, and it's going to be greater than or equal to 7. And there's the second notation. L. Okay, I have to get everything on the same side. I did it in two ways. Let me first show you this way. So what I did is I took the 2x over, it became minus 2. I took the 3 over, it became minus 3. Then I factorize it. I get my two 0 points. It's 3 and negative 1. That is standard form, before I factorize. The question is asking smaller than. That's how I know it's in between the two 0 points. Now, if I show you the second option, that is why our sign will have to turn around. If I took the x squared to the left-hand side, I would have negative x squared plus 2x plus 3 greater than or equal to 0. Ne? Okay? If I have that, that is not standard form, because there's a negative in front of x squared. So what I'm going to have to do is I'm going to have to multiply every term with a negative. And when I do that, I'm also going to do it on the other side, and then my sign has to turn around. So whether this expression is on the left-hand side or on the right-hand side, because I'm following my rules, in both cases it's asking this whole thing smaller than 0, this whole thing smaller than 0. And that's why we have to turn that sign around when we divide with a negative. Do you all understand? Okay. It's not that hard, ne? And it's work that you can study. So I'm going to quickly do something, activity with you. And we're going to finish, and then you won't have any homework for tomorrow. But then you have to work with me now, so we can go through it very quickly. So there are two parts in this chapter that we didn't do yet. The one is equations with fractions, and the other one is word problems. But those are two things that they very seldomly ask in a question paper. Okay, but we're going to go through it. I'm going to just give you a short explanation, and then I'm sure you will be fine in handling it. So I want you to write exercise 7, page 32. And you can write down the equation. Remember what we do when we've got an equation with fractions and it's an addition or subtraction. We find the lowest common denominator. No. Okay, now that's what we're still going to do here. But that denominator is not okay. You did these type of sums in grade 10, am I correct? So what we're going to do is we're going to factorize it. And then it will be x plus 2, x minus 2. And that factorization can be in the numerator or in the denominator. Okay. Now the reason why I had to factorize that is because, do you see, if I didn't factorize that one, I had 3 different denominators. But now that I've factorized it, I only have 2 because it repeats. So what is the lowest common multiple? The lowest common, there it is, x plus 2, x minus 2. Now the moment that we give that LCD, we also have to give our restrictions. Now, do you know why we would have a restriction here? Whenever we have a fraction, there is a risk of dividing with 0. And dividing with 0 is the biggest, baddest sin that you can do. It's not allowed at all anyway. Okay? So whenever, and it will happen in other fractions as well, whenever you have a variable in a denominator, we're going to take whatever is there, let it not be equal to 0 and solve it. So if I do this whole sum and the answer of x is negative 2, that would result in 0. So I would have denominators that are equal to 0. If the answer is 2 and I substitute it in there, I would have 2 places where denominator will be 0 and it will be a math error. Okay, so I'm just going to give the restrictions. It doesn't really influence me any further. Whatever your lowest common denominator is, they must not be equal to 0. Now when you found your lowest common denominator, you are actually multiplying that whole thing at the top. And that makes them cancel out in the first term. When I multiply that whole thing at the top there, the x minus 2 will cancel out the x minus 2. And then I only have to multiply in x plus 2. Do you understand? Then I take that whole thing, I also multiply it with the last term, even if it's on the other side. I multiply it there, and then the x plus 2 and that x plus 2 will cancel out. And then I'll have negative 1 that only has to multiply with x minus 2. Are you all happy with that? I don't think it's difficult. Okay. So now at this stage, 3 things can happen. You will either have a trinomial once you get all your x's on the same side, or a quadratic equation, and you'll solve it, you'll get 2 answers, and that will be it for x. Or it can happen that you have x on the one side and constants on the other side, and you will solve for x like a grade 10 sum. You'll get the answer of x. Okay, those 2 will be the first option. The second thing that can happen is when you take all your x's to one side, it will give you 0. And you take all your normal numbers to the other side, it also gives you 0. So you will, the x is gone. Do you see that? All you have is that 0 is equal to 0. Is that true? So what is 0 equal to? 0 is equal to 0. It's true what it says there. Okay, that's true. Now when that happens, we are going to say x is an element of real numbers. That means x can be anything, because it's going to cancel itself out. It won't be there anymore, and then you'll be fine. But you know we've got 2 restrictions, né? We've already given them there. You don't have to give them again. X is an element of real numbers. So you'll either find the value of x, solving for x, or you'll get an answer of 0 equal to 0. Then you're going to say x is an element of real numbers. And then what can also happen is once you've done everything, you will get 0 equal to, for example, 2. Is that true? 0 is not equal to 2. Then the whole thing will have no answer. Okay, they will never do this in an exam. Never. But you need to know this. And understand why it's no answer, because 0 is not equal to 2. X can be real when 0 is equal to 0. Does that make sense, grade 11s? Okay. Then I just quickly want to show you D. So at D, I've got x squared minus 1 over x plus 1 equal to minus 2. So my LCM will be x plus 1. Now I must multiply everything with x plus 1. Right? So that one I multiply with x plus 1, it cancels out, and that one I multiply with x plus 1. And now my denominator is gone. I also give my restriction there by the LCM. X cannot be equal to negative 1. You understand why, ne? Okay. Okay, so now I can get everything on the same side. This is like what I just said, what can happen, eh? You can just get everything on the same side. Now you see you've got an x squared, so you know you're going to factorize it, normal solving for x. Factors of 1 that will give me 2 when I add them is 1 and 1. So there's actually just one answer there. And that answer will be negative 1. But do you see I cancelled that answer? Why did I cancel that answer? It's my restriction. It would result in an answer of 0 in the denominator. Okay, are you fine? Do you understand? I'm not going to let you practice that activity or that exercise because they really haven't asked anything about this in the last couple of years in the question papers. You can go and have a look in the old question papers. Okay, but you understand why what is happening there. Okay, next thing I want you to write is just word problems. I'm just going to do one example for you. Are you asking a question or stretching? Why is it like this now? You see, I can't even write because you're talking so much. Okay, word problems. When you've got a word problem, you need to get all the unknowns in terms of the same variable. Okay, so what I mean by that, if I tell you that Leakwe is a certain age, do you hear that's an unknown? Okay, so we can call her age X. And I am a certain age. That's another unknown. So that's going to be Y. If I don't give you any more information, it will just be X and Y. But if I tell you I am 2 times Leakwe's age, my age is still unknown, ne? Her age is still unknown. But if her age is X, then mine's going to be 2X. Instead of having X and Y. Does that make sense to you? Why do we want to get it in terms of the same variable? Because then we only need one equation, then we can solve it. Okay, so I've given it to you there. There are 2 ages. The product of the 2 ages is 135, and the difference is 6. So I know if I take the one, I call it X, and I call the other one Y. If I multiply them, it will give me 135. You see I've got 2 variables. Excuse. I can't solve it because it's 2 variables, 1 equation. But because they told me the difference is 6, that means X in comparison with Y will be, and it doesn't matter whether you say it's 6 more or it's 6 less. The difference will be 6. Do you agree? You don't know if the one is 6 more and the other one is 6 less. The difference is 6. Now, do you agree with me? I can take that just like we did the simultaneous equations. I can take that y plus 6 and put it in the place of y. Then it looks like, in the place of x. Then it's going to look like this. X plus 6 times y. I can multiply that y in. I bring the 135 over. I can factorize it. It's 15 and 9 plus 15 minus 9. Y is equal to negative 15. Y is equal to 9. Do you understand what I did to get that answer? Everyone. So if I'm referring to an age, am I referring to negative 15 or to 9? 9. You're not going to be negative 15 years old, ne? You're going to be 9 years old. So that means y is 9. And what is x then? 9 plus 6, it's 15. Easy, ne? So if you had said y minus 6, ne, you would get the answer of 15. And then you would subtract 6 to get the other answer of 9. They're not asking what's x and y. We made it x and y. They want to know what these ages are. They differ by 6. When you multiply them, the product is 135. All I want you to do now is open your textbook on page 43 and you can have a look at that example 15. Example 15. Read the question. Try to close the solution. No? You can, in your workbook, use a pencil. See if you can figure it out. How that will work. It's a tricky one. Okay. And then you look at the solution, how they got to the right answer. And when you're done with that, it's now 43 minutes past 1. So there's like 15 minutes left. You can try it and then you can rest. Okay. The example 15. Yeah, 15. On page